We are very glad to see you in Szeged again. It's not the first time when you came to our city. And I would like to ask you, how much did the Szeged Scientist Academy develop in the last few years?
Yeah. Well, I think the development is fantastic. I mean, when I came first time, it was a program centered in Szeged, with students coming from different parts of Hungary. But meanwhile, the program has developed into two branches, and actually one of these branches aims at revolutionizing science education in all of Hungary, which is something which wasn't present 5 years ago.
You see a lot of talent developing program worldwide, and I would like to ask you which is the main advantage of this program? Why could we say it's unique?
Yeah, well, of course I know very well the program which my wife initiated in my hometown, Göttingen, the XLab, and I think both programs aim at getting pupils in the secondary high school education interested for science, and to give them the experience of doing experiments on their own. So in this respect, the Szeged program for the secondary school is very similar to XLab, except that XLab is just focused or located in one location, Göttingen, and students have to come from different places, some over long distances, whereas here this program has developed into this multi-center kind of thing which covers most of Hungary, that's not present in XLab. So that's one unique feature of the Szeged program. The other unique feature is the other branch of the program, which is geared at students in the first years of their studying of medicine and biology, aimed at bringing them into the lab at an early time point, and getting them involved actually in real science, This aspect also is missing in XLab, It's another item which makes the Szeged program unique.
You have met a lot of students yesterday and today also. What's your opinion about them?
Well, it's very nice and interesting to see all the students, to talk to them, to first answer their questions, scientific questions, which shows that they are really interested in the subject. The other thing is that, of course, some of them are a little bit skeptical. They are not sure. Do they really want to go into science? What it involves? What kind of sacrifices they have to make to do science? Is it really weighed up by the kind of positive parts of science? So we had a lot of discussion for the pro and cons, and how to organize one's life around the fact that as a scientist you are very dedicated. You need to involve much more of your time in your profession, than say an ordinary paid job which starts at 8 o'clock in the morning and lets you get home at 5 o'clock in the afternoon. So,
And what do you think, what are the most important features of the students or young researchers which they have to own to be a successful researcher?
Yeah. Well, as I said, the most important thing is the ability that they can immerse themselves deeply into a problem, that they have the urge to or that they first are able to identify a problem which they are really interested in, and to develop the urge to solve this problem and to stay on the job, so to speak. Of course, having a problem and trying hard to solve it doesn't necessarily lead to an end. They also need certain skills, but these skills that they need depend very much on the topic, on the field that they are in. If you want to say contribute essentially to informatics or computer sciences, you have to have programming skills and skills of formalizing an idea of abstracting a problem and reduce it to the essentials. If you go into molecular biology, you need to know a lot of the background. Then you have to be very patient very often to follow your things, and very systematic. It depends, Mm-hmm.
Yesterday you took a lecture for the students. What was the main topic of your lecture yesterday?
My lecture yesterday had two parts. One was explaining the story of the discovery of ion channels, of developing this technique, which allowed us to resolve currents in biological membranes into components of individual ion channels, which is a topic which brought us a Nobel Prize, And the second part was, once you understand how a nerve impulse is generated, you have to ask, of course, what does it mean if a nerve cell generates an electrical impulse? What's the meaning of it? And I try to point out that in some places in the brain that's very simple, very obvious. The example I gave was that of action potentials in the motor neurons. When a action potential travels from the spinal cord to your toe, it means that the muscle there should contract. So it's a simple relationship between electrical activity and function. In other places, it's much more difficult to find out. And the other example, which I then tried to explain, was the various stages of signals coming through our eyes, how they are processed on the way from the retina, which is the light-sensitive unit and which functions like a camera, so to speak, what the meaning of the signals is as they are passed on to the primary visual cortex, in the cortex, where you find neurons which respond primarily to line contrasts. So there is quite a lot of processing going place, which involves data compression, as it's done in technology in the MP3 players. Data compression is an important thing, but there is also much more sophisticated pre-processing, in the sense that what comes onto the retina is kind of dissected into different features, which then somewhere later in the brain are put together again, so that we get the impression of something we have seen before, that we recognize objects, that we can mix what we see with memories, what such objects have meant previously, So that's basically what I tried to explain.
Göttingen is a very great example for us, for the University of Szeged. And I would like to ask you, what do you think? Is Szeged appropriate to be a good place to develop, for example, a future Nobel Prize winner?
Well, Szeged has some tradition, I would say, in generating Nobel Prize winners. I think Szeged, like Göttingen, is very suitable for the kind of activity that we had last 2 days, because everything is very compact, you know. There are people who enthusiastically drive this program and bring it forward. So there are plenty of facilities, you know, to have all these different kinds of activities. Now the second aspect about future Nobel Prizes, that's of course difficult to predict, you know. It involves a lot of luck, it involves optimal conditions. I think the conditions here are appropriate, you know. I've seen very well equipped labs, I have seen very enthusiastic colleagues, but whether and when this will lead to a breakthrough discovery, which then is honored by a Nobel Prize, that's something which I cannot speculate on with any kind of certainty.
And could you give some advices to the Szeged Scientist Academy, what to do in the future, what should they change?
Yeah, that was one thing I was of course asked already. I think there are these two parts of the program for the university students, which I think is very unique and should just be continued. The other program for high school students is also unique in the sense that it is distributed throughout Hungary and avoids the necessity to travel long distance, you know. But I think the individual hubs, how to call them, you know, they of course are relatively confined things which may offer a few types of experiments for students, offers some experience for the local students, and so I would recommend that there is some interaction between the hubs, that students have the possibility to go from one hub for a few days to another one to widen their experience, you know, some kind of exchange program, say, between the hubs.
Thank you very much.
Yeah, welcome.